Okay, Chapter 4, Day 6, the last topic for Chapter 4. What we're going to focus on are what are inverse functions. So that's kind of a new word for us. And how do we find them? So we're going to take a look at what is an inverse function and how do we find the inverse function. So that's what we're focusing on today. An inverse function. It is a reflection across the line y equals x. An inverse function, if I take a graph and reflect it across the line y equals x, I've created an inverse function. Okay? Something to note here. A function has an inverse function only if the function is 1 to 1. And if you remember, if it's 1 to 1, it has to pass the horizontal line test, or y can't cheat. If we think about a coordinate point, y can't be cheating, all right, when we talked about 1 to 1. So if I take a graph reflected across the line y equals x, you did that in geometry, I've created an inverse function. And sometimes they'll ask, does it have one? And all you have to do is ask yourself, is it 1 to 1? Does it pass the horizontal line test? If it's a set of points, is y cheating? If it doesn't pass or y is cheating, then it does not have an inverse function. There is a way that we use lettering to notate inverse function, okay? So we do f, and it almost looks like it's raised to the power of -1. It really isn't. It's just a way of notation. F with a superscript -1 of x means f inverse of x. So I read this as f inverse of x, or I might say the inverse function of x. That's how I read that. So, for example, you might be given a problem that says, find f inverse of x. Don't say f to the -1 of x. No, it's f inverse of x, or the inverse function of x. If I have given some initial function, f of x function, f of x equals 2x plus 5. So that's given to me. Find f inverse. Okay. Well, here's the steps that we have to follow. It's a process that you have to do. First thing, write the function as y equals. So you need to write it in y equals form. So I'm going to take this and rewrite it y equals 2x plus 5. I need it to say y equals so I can do step number 2. Step number 2 says switch the x and y letters. So go back to this, and wherever you see a y, you're going to put an x, and wherever you're going to see an x, you're going to put a y. Switching those around. So that is step 2. And then once you have the x and y letters switched, you're just going to resolve this problem for y. So you have to go back through the process of just getting y by itself. Okay? So I want y by itself, so I'm going to move the 5. Take away 5, take away 5, x take away 5 is 2y, divided by 2, and x minus 5 divided by 2 is y. Done. There's my inverse function. Sometimes you'll see this in multiple choice written differently because all of this is over 2, or you can write it as follows. X over 2 minus 5 over 2 equals y. Either way. You can write it either way. If it's open-ended, you can leave it like that. If it's multiple choice, you might not see it like that. You might see it written this way. So, write the function in y equals if it's not already. Switch the letters x and y, so x becomes y, y becomes x. And now just focus right here and solve this for y. Get everything to the other side, solve for y. And that is your inverse functions. If you have coordinate points, if someone says, hey, here's the coordinate point, Find me the inverse. Well, all you do is switch x and y. If you remember from geometry, reflection across the line y equals x, y now becomes x now becomes y. So the coordinate point xy turns to yx. So for example, find f inverse for the coordinate point 3, 4. Well, if I switch those around, it becomes 4, 3. It's that easy. There's the inverse. And since finding the inverse of coordinate points is just switching them around, if you are graphing, if you have a graph, sometimes it's not easy to visualize the reflection. Pick some points. Just pick a few points. Switch the x and y values, then replot the new points, and you will have created the inverse. So pick a few points, switch x and y, replot them. Okay? So if we go back up for a second, we had to look at what are inverse functions. They're reflections across the line y equals x. How do we find them? We write it, switch the letters x and y and resolve, or coordinates, trade x and y. All right? Sometimes they will just ask, does it have an inverse? All right? Does the following set of points have an inverse? Well, let's go back up. A function has an inverse function only if the function is one-to-one. So either if it's a graph, we have to pass the horizontal line test, or y can't be cheating. So let's take a look at our points. Is y cheating? Well, I see a y is 1 here, and I also see a y being 1 here. So if I said y is 1, if y is 1, what x did it come from? You can't tell me, because it might be 5 or it might be 6. So, since y is cheating, in other words, my y does not come from a unique x. When it's 1, it could come from either 5 or 6. Since y is cheating, the set of points does not have an inverse. Y is cheating. It's not 1 to 1. It's not 1 to 1. I don't need that there, but. So when we come into class, we're going to practice making inverses of points, inverses of graphs, inverses of functions. Okay? And that's it.